everybody, welcome back to this series where we do a revision of a chapter in under 30 minutes. In this one, we're going to do Heat chapter, Form 4 chapter 4. So what do you need? All you need is a pen and a paper. So let's start. Now, so let's talk about Form 4 chapter 4 Heat. So what is the main thing in this chapter? Now, obviously, we're going to start with this thing whereby you always have to understand this word thermal equilibrium. Okay, so what is the meaning of thermal equilibrium? Now, first of all, let's just double check with everybody. Do you know what is the difference between heat and temperature? Okay, so same heat, same temperature, does it mean same heat? Now, let's talk about this first. Now, heat is an energy, so it is measured in joules. Temperature is something that is measured in degrees Celsius or Kelvin. It is the degree of hotness of an object. Okay. However, two objects that have the same temperature maybe can have different amount of heat energy. For example, if now I give you 100 degrees Celsius of water versus 100 degrees Celsius of water. So although these two objects is same temperature, but their heat energy might be different. Why? Because the one with bigger must have more heat energy. The smaller one obviously will have less heat energy. So this is the first thing that you have to understand. And in exam, they like to ask you what is the definition of temperature and what is the definition of heat energy. So that one first. Okay, once you're done with heat and temperature, let's talk about thermal equilibrium. Now, for example, if now I have two objects that is touching each other, so instead of touching each other, we will say that the two objects must be in this thing called the thermal contact. So guys, thermal contact means they have temperature and then they are touching each other. So if I tell you that my object A is 100 degrees Celsius, and my object B is 0 degrees Celsius. So will 100 degrees Celsius give heat energy to 0? So the answer is yes. Okay, because this one hot, okay, then this one cold. Okay, but now my question is, will cold object give heat energy to hot object? Will the 0 degrees Celsius also give heat energy back to the 100 degrees Celsius? So the answer is also yes. So remember the rule that I say. When two objects are in contact, are touching each other, there will always be an exchange of heat energy. But then, why will B become hotter? Okay, because maybe A give 50 joules of heat energy to the co-object, but the co-object only give back 10 joule of heat energy. So I said they will exchange, but they will exchange different amount of heat energy. So what will happen to B is that your B will be positive. Why? Because take 50, only give 10. So it will be a positive 40 joules. This one will give away negative 40 joules. That's why you will realize that the temperature of A will decrease, the temperature of B will increase. Why? Because he get more every time. So therefore, at this point, are they said to be in thermal contact? So the answer is no, they are not in thermal contact. So thermal contact is only achieved, bila, when your both objects, again in thermal contact, so let's say A and B. Now, what makes this so special is both of them have equal temperature. Okay, when they have equal temperature, will A still give heat energy to B? Will B still give and receive heat energy? So the answer is yes. When two objects are touching each other, there will always be give and take. Okay, so what is the difference now? So A maybe will give 30 joules of heat energy to B, but B will also give back 30 joules of heat energy to A. So let me ask you, B untung how much? Give 30, take 30. So the change in B is 0, the A also 0. Okay, so like the I give 30, I take back 30, so there's no difference. So at this point, this scenario, we call this as the thermal equilibrium is reached. Okay, so it is reached when your two objects have, most important, same temperature. Number two, there is no net heat flow, provided, of course, don't forget your term, they must be in thermal contact lah. Okay, now what is the meaning of net heat flow? Okay, so this word net is very important because net means the difference, no difference. Like for example, in this question, is there a net heat flow? If you give 50 and you only take 10, you give 50 but you only take 10. There is a difference, right? So what is the difference? The difference here is, if we say the net heat here is equals to 50 minus 10 equals to 40 joules. But if you ask me on the right hand side now, if you ask me what is the net heat, give 30, take back 30, my obvious answer here is 0. So there will be no net heat flow, or you can say 0 heat flow. So you have to understand the thermal equilibrium concept first. Okay, where do you need to focus? You have to focus at the heat exchange, or you can look at the temperature. Alright, so when you write things, you must always remember to quote net heat flow, net heat flow, net heat flow. Okay, so make sure you use this in your answer, the word net. So once you faham thermal equilibrium already, okay, is there any checkpoint? Yes. So we have to go into thermometers. Now nowadays in thermometers, the assay already a bit old school. It's a bit probably 5 to 8 years ago important. Okay, now in thermometers, assay macam not so trendy, but they like to ask two things. Number one, calibration of thermometer. Number two, they like to ask the calculation of the calibration in the thermometer. So whereby you have this thing, whereby you take the L theta minus L0, L100 minus L0 times 100. Okay, so if that's the temperature lah. So yes, you need to know this formula. Okay, can, alright. But you are allowed to not use the formula. In fact, in my class, I don't actually recommend my students to use this formula because I feel this formula makes it even more difficult. If you are good with ratio, you can just use simple ratio, alright? So as I say before, I will not do any latihan here. There is an exercise video that I will link in the description below, so make sure you watch the video as well. Alright, okay, what is calibration? So calibration is usually when you have a thermometer. Imagine that now your thermometer don't have scale on it. So when you don't have a scale, you have to find out where is the 0 degrees Celsius, where is the 100 degrees Celsius. You want to find out these two so that after that, you can divide by 100 lines to find all the scale, correct? So now my question is, how to find where is your 0 degrees Celsius, where to find what is your 100 degrees Celsius. So therefore, this one is very important. So we will develop this into pure ice that is melting, okay? Because once it starts to melt, then only that is your 0 degrees Celsius, okay? Then what about the 100 degrees Celsius? You have to immerse it into steam above boiling pure water, okay? Or you can just say boiling distilled water. Some teachers even want you to add at atmospheric pressure. Okay, so that's 0 degrees Celsius. Yeah. So steam above boiling distilled water. So there you go. You need to know how to find the 100 and 0 degrees Celsius. So calibration is very important. Assay is what kind of assay lah, okay? I say not so trendy, bukan tak akan keluar. Okay, so you have to say ways to increase its sensitivity. So how can I make my thermometer more sensitive? Usually there are 3 general rules. Number 1, you're gonna use a thinner bulb wall, thinner bulb wall. And then number 2, you need to use a narrow capillary tube. And number 3 is we will say smaller bulb. Okay, if you don't know what's the bulb, bulb is the bottom one. Capillary tube is the tube inside where your liquid will move up. Okay, narrow, then it will be more significant. Okay, then you also need to know what is the difference between alcohol versus mercury thermometer. Biasanya guys, the rule of thumb, if hot stuff, we use mercury. If it's cold places, we use alcohol. So how you can remember this, very simple lah. If you use alcohol, wash your hand before. Alcohol is really cold, right? So yeah, on thermometer, these are the things. Make sure that you know how to do the calibration calculation. So feel free to go and refer to your textbook. Okay? Now, in thermal equilibrium, usually they will call you to state some application. Like for example, guys, don't forget those application like they ask you, why thermometer if I put into my mouth can measure my body temperature? Because there's a net heat flow. Where is the net heat flow? From the body into the thermometer bulb. So the mercury will expand when heated, and then it will reach thermal equilibrium, so the thermometer temperature will be the same as my body temperature. So those stuff to yourself. Okay, next. So okay, this is just only on 4.1. Now, there's a very big topic here, which is what is the difference between Q equals to mc theta and against Q equals to ml. Okay, so very simple, guys. Okay, Q is mc theta ml is usually mc theta is known as your specific heat capacity. Specific heat capacity, which the unit is joule per kg per degree Celsius, is the heat energy needed, how much heat you need to raise 1 kg substance by 1 degree Celsius. More explanation on the exercise video, but usually we use this when your question has a change in temperature. Okay, so guys, what's change in temperature? Meaning to say that this thing become hot. Like 30 degrees Celsius become 70 degrees Celsius. Okay, so change in temperature, obviously we use specific capacity. Like your theta, that is also your change in temperature. So fun fact, guys, temperature no, this theta no negative one. Go up, also you take big minus small. Go down, you also take big minus small. Alright. Now, so of course, then if I look over to the other side, this L, that L will be known as specific latent heat. But in latent heat, a bit susah. Why? Because latent heat got two types. Got the fusion one, and then got the vaporization one. Okay, what's the difference between fusion and vaporization? So it depends on what state you are. So you will see that from solid to liquid is fusion. Liquid back to solid also fusion. Liquid to gas is vaporization. Gas back to liquid also vaporization. What is the difference? Now when you go towards the right hand side, you technically absorb the latent heat. When you go the other way around, you technically release the latent heat. So for example, if they ask you, what is the process condensation? Why condensation will burn your hand? You know, like when the steam terkena your hand, you will accidentally burn your hand. The reason, very simple. Because condensation allows the gas to form liquid, which will then release the latent heat of vaporization to the skin, which will then release the heat to the skin. So your skin will burn up because it releases the heat to the skin. Make sense? Okay, so like I said, you have to read deeper if you want to know more. Okay, then specific latent punya temperature, because it is only change in state. Okay, so we sometimes say this is change in phase. We also say change in state, which is solid, liquid, gas. So it's only per kg. When you have change in state, usually change in state is related to this thing called the constant temperature. That's why the definition for specific latent heat is the quantity of heat needed to change the phase or state of 1 kg substance at constant temperature. So you must say the constant temperature, alright? So what is there to worry about? Okay, there's a hybrid of these two things. Okay, for example, I give you a contour. Maybe sometimes your teacher might trick you a bit with some sample calculation. Number one, they will trick you with this. They might say something like, if I have water at room temperature, and I want to masak the air all the way it becomes steam at 100 degrees Celsius. So what is the energy needed? So let me ask you a question. If I just say that, so this is just the energy needed Q here is actually just equals to mc theta. Am I right or wrong? So I have students who texted me, teacher, why I do like this, I cannot get the answer. So every single time when you do this conversion, the heat change and everything, always check. This is a change in temperature, correct? So this is mc theta, from 30 become 100. But at the same time, you also have water to steam. So when you have water to steam, there is another ml that is involved. Mass times your latent heat. So that's why always check if there is a hidden latent heat inside. Is there a hidden change in latent heat? So this one is very important, like guys, really very important. MC theta plus ml. MC theta plus ml. So because there's water, there's a change of 70 degrees Celsius and then there's a water to steam change. So what are the things what else do you have to beware in this chapter, guys? Obviously, okay, let's have a look. So you need to know that for low specific heat capacity versus high specific heat capacity, what makes them so special? Okay, usually low specific heat capacity, we call them as heat conductors, and high specific heat capacity, we'll call them as a heat insulators. Okay, so okay, if you try to think about it, so metal and wood. So metal is a contour of a low specific heat capacity, wood is a contour of high specific capacity. So every single time in the exam, when they ask me, do I want to have low or high specific capacity? Sometimes I will just change it and ask myself, will the thing be made metal better or would it be made into wood material? Which one will be better? So basically after that I will know I want a conductor or heat insulator. It's just like house. Your walls should have low or high specific capacity. You pernah listen that people or hear that people stay in wooden house, right? You don't hear people stay in metal house, right? So definitely the walls must have high specific heat capacity because it's a heat insulator. Alright? Now, rather than we say low specific heat capacity, heat up easily. Now guys, the word easily is like very lousy. We will say that what is the definition of low specific capacity? It uses or it requires lesser heat energy to raise its temperature. Okay, so also known as means that it will heat up faster. Okay, so usually I prefer to use the require lesser heat energy to raise its temperature to heat up faster rather than I just say, oh, can heat easily lor. So what is your high specific heat capacity? Cannot heat easily, is it? Yeah, so then this one I will use another way. I'll say it requires more heat energy to raise its temperature. So usually we will say it heats up slower. Okay, so that's how we write our answer. That's how we shape our answer. So make sure you know how to, use your answering lah. Okay, it's a bit of answering technique, that one. So today, this session is just a recap, so I don't waste too much time. Here. Now, what are the potential essay questions in heat? Now, obviously, you have to go through my Latent video to see the essays. But nowadays, the few essay questions are number one. I would say car radiator is a very common exam question. And then what your fridge, your peti sejuk plus aircon. okay? Because it's the same concept. Fridge is basically an aircon concept. So you need to know how it works, explain as well. Then the next one is all the cooking utensils. Do you call them utensils? Like for example, the egg steamer, the pressure cooker, the solar cooker and everything. Now then recently you're gonna learn this thing whereby they usually ask you some containers. So these containers can be like something that stores heat, thermos flask, if you know what's Montego bottle, Stanley cup, okay, even the GrabFood punya bag. Okay, those are the containers and everything. And last but not least, nowadays they ask you some house design, like how do you create a house with proper air ventilation and everything. So these are the few common ones, guys. I did not say this is everything, but if you can do this, it's most of it lah. All right. Okay. Then after that, need to always remember phase diagram calculation, very important. Really, really very important. So what are your calculations? Like for example, here usually we will do PT equals to ML because that's where your phase change happen. Usually here we'll do PT equals to MC theta because that's where your change in temperature happens. So depending on in which stage, which part, what do you need to do? So oleh itu guys, make sure you know how to do this lah. Usually this is theta against T. Alright, temperature against time. So yup, there you go. This is on the heat punya question. Alright. Now a word of caution lah. There is also another mixture calculation which is very susah, whereby usually they use like cold add with hot stuff. So what makes it very difficult is how to form the equation whereby your MC theta punya theta will be tricky. Alright, so like I said guys, the only way you're gonna learn this is if you just watch the other exercise videos that I will link at the bottom. Alright, so in this video we just do recap. Okay, now so once you are good at this thing, okay, you know what happens in the change in state, why do we want high latent heat, why do we want low boiling point and everything, especially the fridge and the aircon guys, you have to know every essay, not choose to learn all. Alright, then this will lead us to our gas law. Okay, so for Boyle's law, Charles' law and Gay-Lussac law, Boyle, Charles and Gay-Lussac. So I use this strategy whereby Charles liked to watch TV. TV is like normal TV. Then after that, boys like to watch porn video. Okay. And then Gay-Lussac, gay like to watch 3P. Okay, 3P, you know. Alright. Now, so this is the relationship. So what else do you need to know? So remember, for gas law, first and foremost, you must know the definition. Like, what is the definition? You have to memorize the definition. There's a technique involved. Number two, then you need to know the formula. Alright? The biggest mistake in the formula is, remember, you need to use Kelvin here and you have to add 273. For whoever who forget, guys, good luck, man, because this is the most common exam error. So formula that when you calculate, especially on the temperature side, you need to change it to Kelvin. You have to add 273. After that, you have to be able to explain the physics concept. For example, what kind of explain like that? Like you have to know like why when temperature increases, for instance, why would the pressure increases? So this is our Gay-Lussac law. Like for example, you have to say when temperature increases, the average kinetic energy increases. Because temperature and kinetic energy is directly proportional, then kinetic energy causes the frequency of collision between the gas molecules on the wall of container. So you have to say the collision between who and who increases, causing more impulsive force to act on the wall, so the pressure will increase. So you have to be able to explain it as well. Alright, why when your volume decrease, your pressure will increase? Because just imagine you go to a smaller room. When your room becomes smaller, the molecules will hit the wall more often, right? So when you have more collision, more force on the wall, more pressure. So this is the relationship of explanation that I want you to know. Last but not least, you have to know the graphs. Okay, I can draw 6 common graphs that they'll ask you. Alright, but for the complicated ones, maybe you will need to refer somewhere else. Okay, so since P is inversely proportional to V, so therefore P is going to be directly proportional to 1 over V. So that's your Boyle's law. For Charles' law and Gay-Lussac law is similar concept. Alright, now if you want to know VT graph, first of all, what do you check? You have to check your scale. If it's Kelvin, which is called the absolute scale, it will be from 0. But if you are going to be asked to draw a temperature against degree Celsius volume, guys, good luck, man. Okay, what you will get here is that you need to make sure that you extrapolate the graph and you have to tarik this line all the way until it reaches the back. How much you reach here? It is negative 273 degrees Celsius. So it is exactly the same for the case of your Gay-Lussac law. Tetapi the only difference now is, wait, not enough space. Okay, wait, let me just. Okay, so therefore you need to know that instead of this is V, the y-axis will become P, and they are exactly the same. So I want you to focus on one trigo. If it's degree Celsius, you have to start at negative 273. If it's Kelvin, everything is good, normal. Alright. So as for how to remember the formula, okay guys, there's a way that every teacher uses this, which is the triangle method, known as the PVT. So if you look at PV, which is for Boyle's law, PV, so PV for Boyle's law is very simple. You just have to remember PV means it will be P1V1 equals to P2V2. Why? Because we only look at PV, Boyle's porn video. What about Charles? Charles watched TV, right? TV is this side. So this is the divide relationship. So V1 over T1, V2 over T2. And then what does Gay-Lussac watch? 3P. So therefore this is going to be P1 over T1 to be equals to P2 over T2. So that's how I get all 3 of the formulas. So guys, which means that I already show you the graph, I already show you the formula. You just have to practice, explain, practice writing and explain with your definition. Alright. Typical gas law questions are like pressure cooker. So this is one of the things that before your exams, you might want to make sure that you are very good at this kind of soalan. So for more information, for more things, you have to do more practices. Okay? Which is the tough part is usually your MC theta and your ML punya essay question. So of course in MC theta, there's going to have this thing called the land breeze and the sea breeze, which is usually exam punya hot topic also. So you have to be able to explain that as well. Besides that, you have to demonstrate the understanding of usually evaporation will cause something to do what? To become cold. Alright? So for example, they might ask you, why is it that when you use alcohol and rub your hand will feel very cold? But if you use water to rub your hand, you feel less cold because the water doesn't evaporate, but the alcohol will evaporate. Understand? Can? So therefore, you need to faham these kind of things lah. Alright. So I hope this video helps you. So if you like this video and you stayed until the end, hopefully you can just drop me a like, subscribe. Hopefully this algorithm will be able to show it to more students to help everybody. And if you think this video is good, drop me a comment to show some support, to let me know that I'm doing the right thing, what the students need, and if you have any suggestions, please put down as well. And remember to watch those latihan at the bottom, and I hope to see you in my next video.